Today we will discuss about vector control, integrated vector control. So what are the methods of control of disease vectors? So we will discuss about it first chemical methods, then we will discuss about biological and source reduction, health education and personal protection. So in chemical, we will use we can use two types of chemicals. It can be larvicidal, so it can be larvicides or it can be adulticides. So talking about chemical control of vectors, we will discuss about insecticides. Insecticides, they are contact poison, they are stomach poisons, and they are fumigants. And talking about anti-larval measures, we can use pyrethrum and mineral oils, and these are natural types of vector control, and these are helpful in elimination of breeding places also. And we can see that mineral oils are effective in control of C. Quinfaciatus, Culex quinquefaciatus, and for a small time, but pyrethrum is more effective in this cases, as pyrethrum temifos and parathion has replaced mineral oil. And how pyrethrum are used? Now we are talking about filariasis control. So pyrethrum is used in a pyrethrum is used as emulsifiable larvicide, and concentration of 0.1 to 0.2% is diluted with water, and emulsion is diluted at the ratio of 1:4. And in filariasis, we will discuss about organophosphorus larvicides. These are parathion, which I already discussed, and temifos, and these are applied in breeding places, and these are anti-larval measures. And in anti-larval measures, now discussing about malaria, we can use in personal protection, we can use nylon nets as personal protection, and we can use mosquito repellents. These are mosquito repellents, and mosquito repellents we can use metadithyltoluamide and dimethylphthalimate and ethyl hexanediol. It is very commonly used. MCQ point: which of the following is a mosquito repellent used in malaria control or any vector control? So option many a times metadithyltoluamide can be given, or the dimethylphthalimate can be given. So this is an MCQ point. And repellents are basically lotions, creams, or sticks. Now talking about adulticides. In adulticides, we can use DDT and methoxychlore. DDT and methoxychlore are from the same groups, and these can be used as residual spraying, and in residual spraying, malathion can also be used, and phenathion, which are from organophosphorus group. DDT and methoxychlore are from organochlorine, and malathion and phenathion are from organophosphorus group. These are used as, and nowadays mostly malathion are used as 2 kilogram malathion powder. 25% malathion powder is mixed in 10% of water. 10 liter of water, sorry, 10 liter of water, and sprayed over 250 square meter area, and this provides a doses of 2 gram per square meter area, and it can be sprayed in 2 coats. These ones are, I was talking about malathion, and the validity of malathion is 3 months, 3 to 4 months, and if this one is an MCQ question, MCQ, and if annual parasitic index is more than 2, 3 rounds of sprays, 3 rounds of spraying can be used every 3 months. And talked about residual spraying. Now we will come on to space spraying. In space spraying, same malathion we can use with equipment fitted. We can see that malathion outdoor spraying is done in the form of insecticide. Insecticide malathion is sprayed in the form of fog or mist, and it is done by ultra low volume thermal fogging method. Thermal fogging method done by aircraft or some ground vehicle fitted, or done with some ground vehicle in which spraying machine or anything can be fitted. It controls the vector quickly. And space spraying we have done in adulticides. And now talking about adulticides in leishmaniasis, like which vector is sandfly. So DDT is used. DDT and malathion are used. DDT is the first choice for spraying in case of leishmaniasis, and 2 rounds per year is done, and at the rate of 1 to 2 gram per square meter. This one is an MCQ point. Please try to remember the doses of DDT needed. And second line of drug is this BHC. These are organochlorine compounds used in leishmaniasis. Now I will be talking about insecticide resistance. Insecticide resistance can occur due to resistance of vector due to certain biological factors, and resistance occurs because toxin is converted into non-toxicant form in the body of insect. It is a biochemical factor and genetic factor. It can be due to resistance transmitted by gene. And insecticide resistance is occurs due to certain insecticides like organochlorine compounds. And if there is resistance, and resistance can be of 3 types. Discussing about types of resistance, it can be of 3 types: resistance with DDT and methoxychlore, resistance with both DDT and its analog, and resistance with HCH and Dietrich group. So it is second type of resistance. Resistance with DDT and its analog is one first type. It is second type. And resistance with both the groups like DDT, methoxychlore means its resistance with both 1 and second type means BSC, all 4. Resistance with all four insecticide already discussed. So it is called double resistance. And when it occurs, the cost of vector management becomes little costly, and so after that organophosphorus insecticides are used, and organophosphorus insecticides like carbamates are used, like malathion are used, and phenthon, parathion, these type of insecticides are used. Discussed about adult larvicide measure. Now I will discuss about biological measures. So these two have been done. Biological measures. In biological vector control, we can use larvivorous fish. We can use larvivorous fish, microbial agents. Microbial agents. We can do genetic manipulation. And we can produce exotic natural enemies of the vector, and by four methods we can use biological method of vector control. So talking about larvivorous fish, these are gambusia fishes, and gambusia fishes are larvivorous. These are gambusia fns, both are gambusia, and some other biological agents we can use. There are notonectides. Notonectides are aquatic insects which voraciously feed on larvae in ponds and rice fields. Hydra are colentrates useful as mosquito predators. Planaria, flatworms, they also feed on larvae. Fungi, culinomyces and coelomyces. We can remember two names, and this is very long. Leptolegnias metarhizium are considerably effective against larvae. Nematodes, we can use Ramanor, Mermisculi, Sivo, Raxand, or Tien Gary. It is under trial. Just write nematodes. And viruses, we can use polyhedrosis viruses and endoviruses. These are also under trial. And we have done microbial agents. And we can also do genetic manipulation. These are also under trial in case of mosquitoes like Anopheles. And it is genetic manipulation that by using some scientific method, genetic method, we can make a mosquito sterile and control their reproduction, and we can decrease their number. And so genetic manipulation, larvivorous fish, gambusia, we can use microbial agents. We can use colentrates, hydra, like, and some bacterial agents. We can also use bacillus thuringiensis, and there are some exotic natural enemies of some vectors. For Mansonia mosquitoes, removal of the supporting aquatic vegetation such as the pistia plant from all water collections and converting it into fish or lotus culture. Dose reduction, we can do it by intermittent irrigation, management of water level, management of water margins, landfilling, channeling, and draining. Can also reduce the transmission by health education in community, school children, TV, and by through mass media like newspapers, by creating awareness in